Good morning. Today I start measurement of phase and frequency of any sinusoidal signal using CRO. It is also known as Lissajous pattern. It is very important because it is the most popular part of the measurement for the gate examination. So numerical based on Lissajous pattern are frequently come in gate examination. One of the most important part of measurement of frequency and phase shift using CRO is also known as Lissajous pattern. So the pattern that appear on the screen of CRT of CRO when the sinusoidal voltage are simultaneously applied to the horizontal and vertical plate, those plate are called, the pattern are called Lissajous pattern. So as you know that in a CRO we have two plates, X plate and Y plate. It is only appear in the dual trace type of CRO having XY mode. If you press the XY mode button, then you get the Lissajous pattern. So for the measurement of phase and frequency, we have to apply sinusoidal voltage in X plate and Y plate individually. So suppose there is a two sine wave because first part is the measurement of phase shift. Suppose one sine wave Vx and Vy, we have to apply two sinusoidal wave on one in X plate, another in Y plate. So suppose in X plate the sinusoidal voltage apply Vm2 sin omega t and Vx sin omega Vy is equal to Vm1 sin omega t. So from this you can observe that there is no phase difference. If there is no phase difference between the X plate voltage and Y plate voltage, then a straight line will appear in CRO screen when you press the XY mode. Suppose how the straight line will come. Suppose we have applied one sine wave across the Y plate whose magnitude is Vm1 and another voltage is applied across the X plate having magnitude Vm2. So you have observed that if 0 to 4 point appear across the center, one point is appear across point 1. Again we have to meet, that means the pattern on CRO is depends on the nature of X plate voltage and nature of Y plate voltage. So if you both the combine, then the locus of X and locus of X plate voltage and locus of Y plate voltage draw the Lissajous pattern or pattern on the CRO. So if there is zero phase difference, then in CRO we appear a straight line, and the angle of straight line from the origin decide by the magnitude of X plate voltage and magnitude of Y plate voltage. So now the X component of this part depends on the magnitude of X plate, and Y component of this straight line depends on the magnitude of Y plates. So if Vm1 and Vm2 are same, then tan theta is equal to 1. That means Vm1 and Vm2 are same. That means if you apply the same voltage having the same frequency, for the measurement of one point you have to notate that for the measurement of phase shift, if you when you apply the two voltage source Vm across the X plate and Y plate, you must we consider that the frequency of two signal must be same. Otherwise, we will not be able to measure the phase difference between two signals. So first condition is that for the measurement of phase across the using CRO, the frequency of two signals must be same. So the tan theta is equal to 90 degree when the tan theta is 45 degree, when the voltage across x plate and voltage across y plate is equal, then tan theta is equal to 90 degree. So the tan theta depends on the Bm1 by Bm2. Bm1 is the voltage across x plate and Bm2 is the voltage across y plate. Or in this way, if the voltage across y terminal, that means y plate is greater than voltage across x plate, then theta is greater than 90 theta is greater than 45 degree. And if the y is same, if the voltage across x plate is greater than voltage across y, then theta must be less than 45 degree. So for measurement of phase shift having zero phase shift, if the two signal have same frequency, when the two signal have same frequency, then the straight line will appear, and the magnitude of the slope of the straight line depends on the magnitude of voltage on the plate X and voltage on plate Y. Next, case 2. Suppose in X plate we have applied Bm sin omega t, and Y plate we have applied Bm sin omega t plus 90 degree, when the two voltages have a 90 degree phase difference. When the two voltages have 90 degree phase voltage difference, so here we have observed that the voltage frequency of X plate and frequency of Y plate are same, are omega, that means 2 pi by f. So if there is a 90 degree of phase shift, so if you draw the curve and then the CRT screen of CRO shows that there is a circle. That means if the 90 degree phase shift, then CRO, the trace of CRO is a circle. And how is comes to circle? So ex square plus ey square equal to Bm sin square square omega t plus Bm cos square omega t, because there is a 90 degree phase shift. So ex square plus ey square equal to Bm square. So in this way, if there is a 90 degree of phase shift, then the Lissajous pattern will appear as a circle. Next, suppose case 2. Suppose the phase suppose Ex plate we have case 3, when the Ex is equal to Bm sin omega t and Ey is equal to Bm sin omega t plus phi, where phi is a phase shift. If the phase shift is not equal to 0 degree or 90 degree, as we discussed, then in case of 0 degree, if the phase shift is 0 degree, CRO appear as a straight line. In case of 90 degree of phase shift, circle will appear. In case of any phase shift apart from 0 degree or 90 degree, CRT in a pattern in a CRO is a ellipse. So suppose there is a phase shift. Suppose there is a phase shift phi across the EY, and suppose that the Bm sin omega t and voltage across X terminal X plate is Bm sin omega t, and voltage across Y plate is Bm sin omega t plus phi. Then the CRO shows ellipse. So when 2 volt, even in case of if the magnitude of two signals are not same, then also we observe elliptical waveform in a CRO. So if you observe how the if there is a phase shift of 0 degree, then a straight line will appear. If the phase shift is 30 degree, so then you the in 30 degree or 330 degree, then ellipse shows that appear in the ellipse is shown in the first quadrant and the third quadrant. If the if the phase shift is 60 degree or 300 degree, then shows ellipse, but almost equal to circle. In case of 90 degree or 270 degree, circle will appear. In case of 120 degree phase shift or 340 degree, then ellipse, but the direction of ellipse means the major axis of ellipse in second and fourth quadrant. That means the direction of ellipse is changes. Again, if the phase shift is 150 degree, ellipse in that appear in second and fourth quadrant. Again, if the phase shift is 180 degree, then straight line, but its slope is -1. So that appear in the second and fourth quadrant. So in this way we can observe how the Lissajous pattern is useful for the measurement of phase shift. So if you conclude the measurement of phase using CRO, conclusion: when two sinusoidal voltage of same frequency are applied in across X plate Vm1 sin omega t and across Y plate Vm2 sin omega t plus phi. So if there is a phase shift of 0 degree or 180 degree, a straight line will appear. And the slope of a straight line depends on the magnitude of Vm1 and Vm2, and the angle between the angle of a straight line is depends on the magnitude of X plate voltage and magnitude of Y plate voltage. Next, if the phase shift is 90 degree or 270 degree, then circle will appear in CRO. And if phase shift is from 0 degree to 90 degree or 90 degree to 270 degree, ellipses appear. So you know that if there is a straight line, so if in a first quadrant and third quadrant, then there is a phase shift of 0 degree. If the straight line in second and fourth quadrant, then the phase shift is around 180 degree. In case of circle, its phase shift is either 90 degree or 270 degree. Or in case of phase shift from 0 to 90 degree or from 90 degree to 180 degree, in case of if the phase shift is from 0 to 90 degree, the ellipse will appear in the first and second quadrant. So the major axis is along the first and third quadrant, and angle that means the phase shift angle sin theta is equal to y1 by y2 is equal to x1 by x2, where y1 is the cut point along the y-axis, and y2 is the maximum value of ellipse along the y-axis, or x1 is the cut point along the x-axis, and x2 is the maximum value along the x-axis. So phase shift angle, that means sin phi is equal to y1 by y2 is equal to x1 by x2. If the phase shift is from 90 degree to 180 degree, then ellipse appear in second and fourth quadrant. Major axis is along second and fourth quadrant, and again the phase shift angle is equal to phi 1 by phi 2 and x1 by x2, where y1 is equal to y1 is the maximum, y1 is the cut when the ellipse cut at point along the y-axis, and y2 is the maximum value along the y-axis, and x1 is the when ellipse cut at x-axis along x-axis, and x2 is the maximum value along the x-axis. So in this way we can measure the phase angle in case of 0 degree to 90 degree or 90 degree to 180 degree by measuring the intersection point along x-axis and along y-axis. So using this Lissajous pattern you can measure the different phase shift, but the condition is that the two frequency two signal have same frequency applied to the CRO, one along x-axis and another along y-axis plate, and its magnitude and phase shift decide the pattern on CRO. If the phase shift is 0 degree, then straight line appear across first quadrant and third quadrant. If the phase shift is 90 degree, circle will appear. In case of if the phase shift is 180 degree, then a straight line appear in second and fourth quadrant. Or in case of if the phase shift is 0 to 90 degree, 0 to 90 degree ellipse appear that major axis along first and third quadrant, and when the phase shift is from 90 degree to 180 degree, 90 degree to 180 degree, then ellipse will appear in second and fourth quadrant, and its intersection point along x-axis and y-axis decide the magnitude of phase shift. So in this way, using CRO you can measure the phase difference between two signals. Next, how the frequency of any unknown sinusoidal signal you can measure using the CRO. So for the frequency measurement, Lissajous pattern may use for accurate measurement of frequency. Signal whose frequency are to be measured is applied across the Y plate, and accurately calibrated standard variable frequency source is used to supply along the x-axis. That means for the measurement of frequency, a signal having unknown frequency are applied across y-axis, and a standard variable signal applied to the x plate. Now you vary the frequency of standard signal that applied across the x-axis. By varying, we have to find out the pattern, either straight line or ellipse or circle. If this pattern is appear on the CRO, that means this pattern is only observed when the two signal have the same frequency. So the unknown frequency of signal must be equal to standard frequency. So in this way you can measure the frequency of unknown signal in terms of standard frequency. But in case if you are not able to find out any straight line or circle or ellipse by changing the standard frequency, then the second method, when it is not possible, then adjust the standard signal frequency to the exact frequency of unknown signal. The standard is adjusted to the multiple or a sub-multiple of frequency of unknown signal. So the pattern appear stationary. So we have to vary the standard signal frequency so that the standard signal frequency is multiple or sub-multiple of the unknown frequency. Suppose we have applied a standard input across the x voltage having the frequency f, and unknown frequency having the frequencies is 2 times the standard frequency. So that means if the if the voltage across y plate is applied to the y plate whose frequency is 2 times the voltage applied to the x plate, then there is a this means the CRO spots travel to complete cycle of a vertical against one in the horizontal line. That means when that means y-axis travel 2 cycle when the x-axis travel only 1 cycle. So we have we getting the this type of waveform, that means 2 ellipses touching to each other. So in this way we have to how to find out the ratio. So ratio is defined by the we have to draw the tangent across the y-axis and x-axis. So frequency of there is a ratio 2:1. That means the tangent touching the two cycle, and in y direction we have touching the only one. So the ratio is 2:1. In this way we can measure the frequency. Unknown frequency is equal to 2 into standard frequency. Suppose the waveform the pattern Lissajous pattern appear like that. So in T, that means the unknown frequency is 3 times the standard frequency, and because the pattern in the horizontal line touches 3 points, and in the vertical line touches only 1 circle. So the ratio is 3:1. Suppose the Lissajous pattern for the measurement of frequency appear in a 4 cycle. That means when you draw the tangent across vertical line and horizontal line. So horizontal line touches 4 curve, and vertical line touches only. The ratio is 4:1. So if suppose the Lissajous pattern appear in this way. So there is 4 1 2, there is a that means horizontal tangent touch 1 2 3, and verticals tangent touch 1 and 2. The ratio is 3:2. So formula: the frequency of fy by fx is equal to number of times tangent touch top or bottom by number of line tangent touches either side. Number of line touches either side. That means fy by fx is equal to number of horizontal tangent by number of vertical tangent. Fy is the frequency applied across the y plate, and fx is the frequency applied to the x plate. So in this way, if the Lissajous pattern appear in CRO, so number of tangent touching the curve decided the ratio between the two frequency. So in this way you can measure unknown frequency in terms of standard frequency, because you know that unknown frequency we have applied across the y plate, and standard frequency we have applied across the x plate. So fy by fx is equal to number of horizontal tangent by number of vertical tangent. So a special case when there is a half tangent. So that means when the Lissajous pattern are open. So in this case horizontal line touches 1 2 and half. So fy is equal to 2 plus 1 by 2, and vertical line touches 1, or half plus 1, half plus half, that means 1. So fy by fx is equal to 5 by 2. You can also measure the touching point by half cycle. That means how the touch the waveform to the horizontal line. That means 1 2 3 4 5. So 5, and there is 1 and 2 to 5 by 2 to fy by fx is equal to 5 by 2. So in this way you can measure the frequency of any unknown signal in terms of standard frequency. That means we have to apply unknown frequency in y plate and standard frequency in x plate, and varying the standard frequency, so that the standard frequency signals frequency must be a multiple of multiple of or some multiple of unknown frequency, and so and the CRO appear as a Lissajous pattern, and number of tangent of along the uh, along the horizontal axis, and number of tangent along the y-axis decided the ratio between the fy by and fx. In this way we can measure the unknown frequency of any signal in terms of standard frequency. So in this way CRO is useful for the measurement of phase and measurement of frequency. In the next part I will discuss how this theory is applicable for the measurement of phase and measurement of frequency in a numerical analysis. So we have to go through this theory and try to understand, because it's very more popular and important for any GATE examination or any competition examination. Thank you.